can AI be biased? And the short answer to that is yes, it can be biased. And it is biased. We just do a quick Google search and you'll find different articles that show how it is biased. So what do we mean by bias? What do we mean by bias in artificial intelligence specifically? Well, in artificial intelligence, you know that it makes decisions, it gives output, it classifies stuff, pictures, things like that. So if it's biased, then the output that it gives, so that classification, the predictions, the decisions that it's making, that can be biased towards a certain group. We're going to look at 6 ways that this happens, but I want to start with a very practical example of the way the bias can sneak in and you may not even know it. So let's say you are conducting employment tests and your employment test is not validated. There's a ton of examples out there of people doing employment testing with non-validated tests. What that means is they're not certain that they're testing the individual on stuff that actually matters, believe it or not. So if you can have a great test, but if it's not testing on the appropriate content, guess what? You can bias a test really quickly. One simple example is giving somebody who's a sheet metal mechanic, and the sheet metal mechanic takes a flat piece of material and does what they call flat pattern layout so they can bend that material and make a 3-dimensional object. Well, it takes trigonometry to be able to do that. They run through trigonometry, use their calculators, do all sorts of stuff like that. So if you only give a written trigonometry test as the litmus test of whether they're qualified or not for the job, you're going to disqualify a lot of people who may be qualified. Because not all sheet metal mechanics go through, a formal process where they say, okay, this is trigonometry and this is the way to do it. They're taught on the job. So if you want to make this bend, you have to use this cosine, whatever it may be, and they plug it in their calculator and they use it. So you could be disqualifying some very capable candidates and not realize it. So if people were trained on the job as opposed to from a specific program where they said this is trigonometry and taught them trigonometry, and you give a trigonometry test, only the folks that went through that program are going to most likely pass that test. So you're going to have a huge bias against people that didn't go through a particular program. So now fast forward. So let's say that's a group of people. So let's say mostly men went through the program and women mostly learned on the job, or vice versa. Mostly women went through the program, mostly men learned on the job. Well, guess what just happened? Since we disqualified all of these candidates, either male or female, who did not go through the program, the formalized program, we are introducing bias into our AI if we use that data. Because what is happening? Well, we are incorrectly disqualifying candidates, and there will be a disparate impact on particular groups. You just have to run the statistics and find out which group has disparate impact. So which group is being impacted more greatly than other groups. So now that we have that data going into AI, guess what? The AI is now being trained on faulty data. So it's going to put forward candidates that fit the data set that we gave it, that we trained it to. And now, dun, 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 it's going to further perpetuate the bias. And we can see that there are many, many different examples that we can go through. The sheet metal one is just one of many. So another one would be if we had an apprenticeship program, and the requirements was a high school degree. That's it. You had to graduate high school. But we're testing them on their mechanical skills. And I saw this happen as well. So the test for mechanical skills, they call it mechanical aptitude, but it was stuff that they could teach within 60 seconds. So they had a huge bias. And in this case, it was against females getting into the apprenticeship program. And they wondered why the apprenticeship program was 80% male, 20% female, because they were disqualifying candidates who, in the candidate pool, the females that they had didn't have mechanical experience. But as an apprentice, you weren't supposed to have mechanical experience. You didn't need it, but they were testing mechanical experience. So it pushed out very good candidates because the only qualifier on the documentation was a high school degree, high school diploma. So there was a disparate impact against females. Now, if we use that data, guess what? The applications that it's going to put forward for the apprenticeship program in the future are going to be biased towards males. So that's how we introduce bias into our system, because we bring it ourselves. Now, what's important about that is that we look for that and we consistently train our AI tools, consistently look at the outputs of our AI tools and test it to see if it is giving us a biased output. So here's 6 ways that it can happen. Now, we just went through the data bias. We talked about that one, gave 2 separate examples with the sheet metal individuals and the apprenticeship program. So we can introduce bias through the algorithm, and it's called algorithmic bias. And algorithmic bias happens when bias is introduced into the algorithm. And how do we do that? We simply design or tune our algorithm to inadvertently favor certain groups. And confirmation bias, you've probably heard of confirmation bias for us as well. And confirmation bias basically happens when the AI system reinforces its current bias, its existing bias. So it's actually programmed to prioritize information that confirms a pre-existing belief. Label bias, now in supervised learning, so there's unsupervised and supervised learning, and there's a hybrid where we do both. In supervised learning, labels are assigned to training data, and people input the labels. So we're introducing that bias again from people, so we have to be very careful on the output. So that data can introduce bias if the labels are not accurately represented, and that can happen in a number of different ways. Societal bias is the 5th one, and AI can reflect societal bias. So one societal bias that happens quite often is individual versus collective. So some value the individual more, some value the collective, the team, the larger group more. And that's really we're going to dive into that deeply into week 4 when we start looking at ethics and we get into the modern day trolley experiment with self-driving cars. That's going to be a lot of fun. So stay tuned in week 4 when we dive into that sort of conundrum that comes up with AI. AI systems can create feedback loops where biased decisions are reinforced over time. So what does that biased feedback loop look like for instructional designers? Could it be that it continues to put forth information and content that's not completely true, kind of like the myth of learning styles? APA has called out learning styles as a myth for many years now, but it's still pervasive within a lot of what we do. So type into a GPT and ask it, hey, what's my learning style, or something like that. And if it's trained in a way that has that pervasive myth from society inside of it, guess what? It's going to tell you all about it, and it's going to present it as if it is true when APA and multiple other organizations have called it not. So it's kind of interesting, and it's always a great conversation to have. So those are the 6 ways, well, not the only 6. So those are the 6 methods, 6 ways where we can introduce bias into AI inadvertently.